for coming tonight, guys. This afternoon. Anyways, so I'm Kim Arjun.
I'm Abby Brasington.
I'm Paige Golden.
And today we're going to talk to you guys about the N1 response to motivational stimuli by using ERP.
Okay, so before we change the slide, I'm going to ask you a question on the next slide. So I'm going to need you to pay attention. Just look at the screen. Okay, everyone looking? Yes. All right, what is the first thing you notice about this picture?
Snake. Yes.
Very good, okay.
So since many of you said snake, going off of that answer, this shows how negative emotion can influence prioritized attention. So what happens when you see that snake, you kind of tone into that snake. You don't really pay attention to the leaves, you just see the snake. But previous research by Gable and Harmon Jones has shown that it could be motivation rather than that negative emotion thing you just experienced. And then early brain activity has shown that in high motivational images compared to neutral images, that there is more brain activity for motivation, but it is unsure if that sensation is from motivation or if it's actually from arousal. So for our study, we investigated the effects of positive images with varying motivational intensities. And we did the positive images rather than negative, so we don't have that negative emotion effect. And we also looked at anxiety, so different levels of anxiety may lead to difference in attention.
So with all this talk about brainwaves, you guys are probably wondering, how do you guys read this? And so we use Electroencephalogram, which is known as EEG. And as you can see here, the researchers are hooking the participant up to an EEG cap. And we read event-related potentials, which is electrical activity from the brain. So as you can see, we're inserting electrode gel, and that helps conduct these electrical impulses that come off from these neurons. And what is the N1? So the N1, as you can see here, is this peak amplitude, and the N1 is a representative of attention. So as the N1 increases, so does your attention. And so we wanted to know, does motivation or arousal affect this N1 amplitude? So for our picture sets, we had high motivation images, which are desserts, and we had low motivation images, which were puppies and kittens. And along with that, we had a control. We had neutral rock images, and these acted as a baseline for us. So as you can see, this is a researcher setting up the electrode cap, and our participants were given a lot of paperwork to fill out as we were hooking them up to the machine. And the most important piece of paperwork that we had was the Beck Anxiety Inventory. So the Beck Anxiety Inventory is a way to quantify anxiety. So it asks questions like, do you experience numbness or tingling? Are you wobbly? Is breathing difficult? And participants rate this on a scale from 0, which is nothing, to 3, which is strong. And based on how you calculate these numbers, this gives us an answer on how anxious a participant is. Along with that, we also primed our participants by using Navon letters. So we had two groups, a local group and a global group. For our local group, they were more detail-oriented processing, and they would answer for this. This would be an L. For our global group, we saw a more holistic view, and they would say that this is a T.
Okay, so who of y'all have actually been paying attention? We're about to see. Because, so I have a couple examples up here, and I'm going to ask you to classify it either as, I want you to classify it as the local conditioning. So again, the local conditioning on this one was an L. Alright, so what was it on this one? L. H. Great, y'all are awesome. Y'all all could have participated with us.
Along with that, so to reiterate, we had these 3 stimulus groups, and in order to get the ratings for these, we did a pilot study where we asked people to give us motivation ratings, arousal ratings, and valence ratings. And we also had our own participants rate these after the experiment, so we could look and see that it was consistent across groups. And we looked at these numbers in order to make an ideal image set that would be highly motivation rather than highly arousing. And so for our participants, what they did while they were hooked up to the cap, we showed them a Navon letter first to get them into that level of processing, either global or local. Then we showed them a fixation cross for 3 seconds, and then after that we showed them an image. So for our hypothesis, we expected that as the motivation factor increases in the images, so would their N1 amplitude and motivational attention. And along with that, we thought that people with higher anxiety would also show this increase in N1 and motivational attention.
So So specifically for our experiment, we focused on the N1, as Kim has very well said. So we looked at the local group, which you saw what that was in our name on letters. So for this graph, we looked at the CZ electrode, which is in the center of your scalp, in case you want to know where that is. And this graph shows animals in red, desserts in yellow, and rocks in green, and it shows time in milliseconds. So we were focusing on 100 milliseconds, and it shows the N1 at this time. And it shows that there is a difference between animals, desserts, and rocks. But as Abby will get into later, we did find that there wasn't as significant of a difference between animals and desserts.
So an important thing to note is with EEG, we're able to read brain waves before you're consciously aware of your processing. So here at 100 milliseconds, people aren't aware that they're staring at an image, however their brain is responding to that stimulus. So this is going to be a video of the comparison between the animal and rock group for our local condition. And when you see red, that shows a significant difference between their N1 amplitudes. So here is the EEG cap, and around 100 milliseconds here, this is a significant difference between their N1 amplitudes. And this is at 300 milliseconds for conscious processing. And we can show you guys that one more time so you can see the difference. So this is coming up to 100 milliseconds, and then after this is around 300 milliseconds.
So as we mentioned earlier, we were looking at anxiety as well. So as Kim mentioned, we looked at the Beck anxiety inventory. We use that to kind of put a number with the anxiety level. So as this graph, you can tell that there's a correlation between anxiety and the N1. So as the Beck anxiety inventory score increased, as did the amplitude with the N1.
Okay, so basically what we found was, well, we kind of confirmed our hypothesis, kind of not. So what we did find was that there was no significant difference between that of the desserts and animals, which is what we did not predict. However, we did predict that there would be a significant difference between that of the rocks, which was the neutral stimuli. So there was a difference between the rocks and the animals and the rocks and the desserts. And then also we talked about that we looked at anxiety. And so basically the people who had higher anxiety levels, they were like hypervigilant almost, and they were already tuned into the image before it even came up on the screen, and they were just very engaged and very observant. And so they had higher N1s. And then so future directions that we're looking to go with this research is we want to look at how high motivation images lead to greater N1s, and through that it's by the rated by the participants, like we've already mentioned with the pilot studies and everything. And then we also want to look at how stress, and in ours it's based on cortisol, can correlate with higher N1 activity. And so throughout the process of experimenting with the participants and everything, we collected saliva samples, and so we will be hoping to analyze that data soon. And then also we would like to look at if images with higher N1s lead to a better recollection. So we would like to thank all of you for coming here today. I know you took time out of your day. I know it's busy, so we really appreciate you coming. We'd like to thank all of our participants and the summer grant research that made it a possibility. And of course, a huge thank you to Dr. Steinmetz for putting up with us this summer and for letting it be a possibility, and the psychology department as a whole. So thank y'all so much.
We have time for a few questions. Any questions?
Do you think that chocolate desserts would have led to higher motivation?
We had a mixed variety of desserts, like in the picture slides, but yes, for me personally.
Yeah, that's what I was strawberries.
Yeah. And like we said, it was really cool because we rated the images ourselves as well. So for me, I honestly thought that the animals were more motivating, because when I saw like, the little kitten, I was like, oh, I want that.
Yeah.
So then we found that with our results that there wasn't really a significant difference between those two groups.
Yes.
Could you reverse your study and use the height of the N1 amplitude to actually assign a motivational index rather than using a subjective motivational index and then trying to see if it had an N1 value?
I'm sure that could be done. It would be really difficult though, because it's really time sensitive as far as reading all of this information goes and looking to see when the stimulus is and when the actual response is. I mean, it could be done, but I don't think we have the time to do that.
Any other questions?
All right, well,
Great.
awesome.
Thank